So we've already used the return statement, I believe. And now we're going to get formally introduced to it. What does it do? Ends the execution of a function. You can put it anywhere in the function. Typically, the right place to put it is at the end of the function. But statements that follow the return statement, at least in that block, will not be executed. You can use it to prevent abnormal termination of a program. I hope it explains how. In a void function, you can leave out the return statement. And if that's true, the return statement ends, or the function ends at its last parentheses. So we've seen this stuff before. We've been using return values already. So like if you have something that does this, int divide, right, and it takes two variables, a numerator and a denominator, right? And then so you have a result, or heck, maybe you're even going to return it as a float, because if you divide one by, as a matter of fact, I'm going to make them all floats. Anyways, so double result. Something could go wrong, right? We could try dividing by 0. We could check for that. If y is equal to 0, then print out some kind of error message. What are we going to return in that case? I don't know. 0 seems like a good thing to me. But anyways, so then we calculate it. Result is equal to x divided by y. Once we get our result, we return our result. That makes sense, right? If you have a void function, divide and print, it doesn't have to return anything. So, right, we do double result, and then we call divide. Result is equal to, divide 1 by 2. We print that out, C out. The result is followed by, the result. I know I've missed something. Right? It doesn't need a return statement. It doesn't give you an error if you put one. Right? That's optional because it's void. Now, what if you have up here more than one possible outcome? Say that we thought that this would crash the computer, or no, not the computer, but the program, if you tried to divide by 0 using floats. Now, I personally don't recall if that's the case, and I guess I'm going to go ahead and launch, Visual Studio in the background just so it's ready for me in a minute. But anyways, what if I wanted to check for that before I did my division? If y is equal to 0, I might want to print an error message. See out, error cannot divide by 0. And then I might want to return right out of it. Maybe I ought to return some kind of error code, right? Or, but I'm just going to use 0 at this point. The better thing to do would be to use references, like we talked about on Tuesday. You return an error code, either true or false, whether it worked, and then you pass the result in as a reference. But anyways, so why do we have this here? So if it hits this point early, it won't do the rest of it, right? So if y really was equal to 0, it prints out an error message, and then it stops. It returns 0 right away. It doesn't do this if this is the dangerous code. You don't do this just for dangerous code, Now, it's considered good programming style to only have one return statement in your code. Why? Because if you have 100 lines of code in your function, and then you have some, return statements kind of tucked away down in the middle of it, it can be hard to follow. It can be hard for you to read it and see all those return statements. On the other hand, there's another programming style which says that it's also totally cool to just rule out all the error codes at the beginning, right? If something, return an error code. If something, return an error code. If something, return an error code. And then once you're pretty sure it's going to work, then you enter the main body of the code. So those are two acceptable ways, you know, of handling multiple returns. Or when I say two acceptable ways, either just one at the bottom, or, you know, rule out the air conditions at the top. Now, is that always strictly possible to structure your code like that? And probably not. This does kind of make sense, right? You know, if I wanted to, I could put an else here, but do you see why I didn't have to put an else here? Because if it returns, there's no way it could come down here. But maybe you like seeing an else for every if. If you wanted to put an else, that would be fine. If it's declared as a data type, it has to return something. If this was commented out, it wouldn't compile. The exception seems to be main. If we don't put a return statement down at the bottom of main, it still compiles in Microsoft C, although it shouldn't. So anyways, we see how return works. You can use it to calculate a value. Here we're using it to calculate a value. We return it. This one doesn't need to return anything because all we do is we calculate a value, we print it out, and we don't do anything else with it. We don't pass it back to main. So down here in main, right, int main, we could call that function. We could call divide and print, if I could spell it right. Right, like that. So if we follow the order of things, divide and print is going to jump up here, and it's going to start running this code. And then it's going to call result. Now, if I was dividing 1 by 0, that's going to be a problem. But anyways, it'll jump up to this method, it'll start running. But y is equal to 0 because this 0 filled in y. And so it's going to print out the error message, error cannot divide by 0. Then it's going to return 0, and so that gets stored there, right? Because that's what return means. Return causes this function to pass back a value. So that 0 gets stored in the result variable. And then when we print it out, it'll say the result is whatever. What would be a better way of writing this now that we know about references? Something like this. I'm just going to scroll down and do it at the bottom. Bool, so to return true or false. And I'm going to call it try divide. And it's going to take two variables, double x, double y, double result. But it's a reference, so we have to declare it with an ampersand. The ampersand sign means it's a reference. And so what do? We check right away. If y is equal to 0, we have a problem. Return false. Else, we could return the good stuff. And remember what I said about if you have a return there, you don't have to put an else. Just to save code on the screen, I'm going to go ahead and do return x divided by y right there. And strictly speaking, I don't even need these braces because there's only one line of code. And when there's only one line of code, you can skip the braces. Okay. But at this, no, I've done it wrong. I've totally done it wrong. Why is that? Can anybody spot the horrible error I just made? What is my return value declared as? It's bool, which means it's going to return true or false. Now what? This one's fine, but the error is going to compile this, flag this one as an error. Why?
It's not Boolean.
That's certainly not Boolean. Right, so what we would do is say that the result is equal to x divided by y, and then we would return true to show that it worked. And then down in main, when we were ready to call it, you know, bool okay, not book. Bool okay is equal to try divide. We want to try dividing 1 by 2, but we need to pass in a variable to be our result. So we would declare something to hold our result. And then we would have to check the response. If it really is okay, we could do something with it. See out result is, you know, else see out oops didn't work for whatever reason. that make sense? If we hadn't declared this as a reference, we wouldn't get any value passed back out. Why do we check to see if it's okay? Because if it's not okay, we didn't even change result. You know, we declared result here, but we didn't put a value in it. So when it comes through here, and then we return this way, nothing ever filled it in. So if we try to print it down here, it would be an error. So we check the return code. This is a very common programming paradigm. You pass stuff in as pointers or as references to get your data back in and out, and then you return an error code if it's wrong. Now your error code could just be true or false, or it could be more complicated. You could return a 0 if it's okay, and if it's non-zero, you know, you could return a list of error codes. You know, a 1 means this, a 2 means that, a 3 means that, a 4 means that. That's still kind of old school, because nowadays a lot of people use what are known as exceptions rather than error code returns. But tuck this away in your brain as something that you can do in C++, and it's a perfectly good way of doing it. Any language that supports references will do this beautifully. If it doesn't support references, like Java, you can still kind of hack at it to get it to work. You just make this a reference type rather than a primitive data type for you Java guys. So returning a value from a function. Well, lo and behold, we just did that. A function can return a value back to the calling code. You've already seen the POW function. It returns a value. So somewhere in our C++ libraries, there's a POW function. Let's see if we can find it. Let's go ahead and make a new program. New project, empty project. Type in all of our usual rigmarole. Let's have a race, see who gets it typed in first. If you've got it saved as boilerplate, you're going to win. Source file, add, new item. By the way, I just graded a quiz that asked questions like, what do you include for for handling C in and C out? And it's IO stream. So if you type the whole word like that, the whole phrase, that's a correct answer. If you just passed me, if you just specified that in the quiz, that's totally good. If you did that, that's totally good. What gave me pause is if there was a syntax error, like if somebody typed that into the quiz. Yeah, that's the right answer. That's the library that you include, but your program would not compile. I couldn't decide, do I count you right or do I count you wrong? In that case, I counted you right because I asked for the library. I didn't ask you to type the include statement. So you knew which library. But no commas there. No leaving the braces out. No putting this, You can put this in quotes under special circumstances. If it's a header file that you have made, like we did last week or something like that, then yeah, then you put quotes around it rather than angle braces. What's the difference? Quotes means that it's stored in the same directory as your CPP file. It doesn't have to go search for it. But if you have angle braces, it tells it to go and search the C search path to find the IO stream library, which is a good thing because we don't have the IO stream library away right in our source directory, do we? So it has to go and find it. So that's wrong. Just because I typed it up here, don't think that suddenly we're going to start doing that. It's when you create your own header files, you put quotes around it. Unless you move your header files to, the search path rather than there. All right, I've talked well more than enough. Pound sign include string, using namespace, std, int main, system pause. Return 0. So why does main want to return a value? So that if you call this program, when you run it from the operating system, if you've called it from a script, you could check its return value. Right? Like you could write a bat file that called main. Or if you're a Unix programmer, you have different kind of scripts, bash scripts and C shells and this and that. And so, you know, you could call your program, and if it returned to 0, you assume that the program worked, and if it returned something else other than 0, you assume that it didn't work. Or whatever it needed to return, right? Maybe it's going to return a file name. Maybe it's going to return the result of a complex calculation, but whatever. So that's why main can return a value. And by the way, that's the difference between this and Java. Java is running in, no, I'm not going to even talk about it. It's not the Java class. Okay, so where was I going with this? I was going to declare some kind of functions, wasn't I? I spaced out. I talked so much that I don't remember why. Oh yeah, just the POW function. I want to take a look at it. Yeah, the POW function. Okay, so double x is equal to prisoner of war, 1 to the power of 2. Okay.
I'm sorry.
I know, I'm just teasing you. Right. The Pow function. Okay, so right-click on POW and go to definition. We want to see where POW is defined. And it'll open up some header file. XTG math. And we look at it, it's pretty complex. They're using techniques more sophisticated than us. That's okay, they're allowed to, right? It looks a little bit alien to us. And we're not going to really understand all this even by the time that we're done with this class. If you're going to become a C programmer, you're going to want to continue studying it even after this class is, because, you know, this class is, you know, level 1173. It's pretty low. I don't think that we're currently teaching an advanced C++ class right now. We're teaching C# next in the fall. I recommend that you take C#. It's a cool programming language, and we'll be able to do more with it than we have done in C++.
Is it offered here?
Yes. Yeah. And guess who's teaching it? So anyways.
How many classes do you teach? I know, you teach like everything.
No, but I am the programming teacher. So I tend to teach most of the programming classes, but there are other programming teachers too, because we have too many sections of fundamentals, right? And too many sections of scripting. So
You can do them all.
I could if they would let me teach 20 classes a semester. Man, I'd be rolling in dough, but you know. Alrighty.
You won't be able to breathe.
Right. Okay. So in a value returning function, your fundamentals class may have called it a fruitful function. The return statement can be used to return a value, right? Here we're going to add number 1 and 2, and we're going to return the result. I love it when we've already talked about something so many times that we can just fast forward through the PowerPoint. Doesn't mean that you shouldn't look at the PowerPoint yourself. But if I skip a slide, it's because I know that I have talked about it like 2 or 3 times already. Another example. We're going to write a function called square. We don't trust the POW function. We're going to write our own. Double square that takes a number as a parameter. Then it multiplies that number by itself and returns it. We feel like adding some of these functions to our code? Why not? It's always a good idea to get extra practice doing functions. So, int times 2. We're going to write a function that takes a value and multiplies it by 2. And I'm going to make it a double. And I'll explain why in just a minute. Actually, if I take a double as an input, I should return a double as well. So I'm going to change that data type from int to double. Now all I really have to do is return 2 times the value that was passed in. What I could do is, you know, create result, and then result is equal to 2 times value, and then return result. You know, I could do it in 3 lines, I could do it in 1. Usually I do it in the 3-line way, even though that seems, you know, kind of superfluous. And the reason why is I could set a breakpoint and examine that variable or print it out before it returned. But I'll live like that. Okay, so that's the times 2 method. Now let's do the inversion method. I think that's what it's called when you divide, you know, 1 by 3. You know, it's the inverse of 3. I hope that's true because that's what I'm going to call my function. Invert my value. And then return 1 divided by that value. Now I'm really curious what happens if I pass in 0. If it's going to crash the program or not. I already remember in Java what the rules are. If you divide by integer 0, it crashes the program. If you divide by floating point 0, for some reason it does it, but it sets that variable equal to an arbitrary, weird constant value. Alrighty. Let's call a couple of these functions. Let's declare a variable first. Int var is equal to 3. Cout times 2 of that variable. NDL. And then cout the inverse of that. Come on, can I type? Cout arrow invert that variable. Now, even though I'm trying to space it out nicely, Visual Studio is correcting my spacing for me. It's very bossy that way. And if I was worried that y'all didn't understand functions, I would go and I would add print statements, right? Times 2 entered, you know, times 2 exited, invert entered, you know, something like that. But I don't think we need to do that. Y'all have done functions in prior programming classes as well. Alrighty, so 3 times 2 is in fact 6. 1 divided by 3 is in fact 0.333. So I'm going to change var to 0. This is just curiosity. Yeah, check it out. Check out what that function returned. It returned a number that when C++ tries to display it to the screen, it calls it infinity. $inf. And if you've ever done math, you know that the smaller the number, like if you divide, this is just point, not really important to our class, but right, you know, 1 divided by 0.5 is 2. 1 divided by, you know, 0.1 is 10. 1 divided by 0.01 is 100. Notice how as the denominator gets smaller, this gets larger. So 1 divided by 0, what is that? Well, it's like you have one cake and you're dividing it amongst 0 people. How many slices does each people get? Doesn't make any sense. But since it was increasing, the closer it got to 0, then okay, yay, infinite. While we're talking about functions, let's just play with this idea. Let's divide by smaller and smaller numbers and see what results we get. We have this invert function, which is going to make it real easy to write that. So let's write a function. I can't even think of a good name for it.
Good name.
Yeah, good name. All right, maybe we're going to do divide series. So, we're going to start x off at 100. Let's write it as a while loop. Excuse me, a for loop. For x is equal to 100. Keep going while x is greater than or equal to 0. And each time we process, subtract 1 from x, x minus minus. Now I made a boo-boo. I did not give a data type to x. Alrighty. So let's print out the inverse of each one of these. Inverting, end quote, arrow, arrow, x, arrow, arrow, space equals, space, end quote, arrow, arrow. And now we're going to call our cool function. the invert of x. And then lastly, arrow, arrow, E and DL. And you know why I put it on multiple lines. You don't have to do that. All right, now if I run it, it's not going to do a darn thing different than what it was doing before. Why is that? I never called it. I wrote a function. I didn't call it. So yeah, why don't I scroll down to main and just call my new cool function, div series. There were build errors. Check my error list. Remember, you can always double click on your error list. It'll take you straight to the line. Alrighty. Must return a value. Why am I getting that error? I made it a double, but does it return anything? No, it doesn't need to. So, void. Or I could have made it return 0, right? But is there any reason for it to return anything? No. Alrighty. So if we watch it, so the inversion of 100 is 0.01. The inversion of 50 is 0.02. The inversion of 10, I did this the wrong way, right? The value got larger and larger and larger, and I wanted to prove that it got smaller and smaller and smaller. So, oh well. It felt good to write a loop.
What? No, I think that.
Oh yeah, I said that it was going to get larger. You're right. I wanted it to get larger. Where it would get really interesting is if we started passing fractional values.
Yeah, if you got less than 1, then
Right.
the number would blow up, would expand.
Yeah. So this wasn't cool enough. We didn't get this quite right. How about we start it at 1, and each time we subtract minus equals 0.01. It's going to get smaller and smaller, right? And it better not be an int anymore. Float or double. Remember, don't put a space between a minus and the equals. All right, cool. It got larger and larger and larger. It never divided by 0, though. That may be due to some kind of rounding error. Floating points are not precise. You may think that they're because they support decimal points, that they're precise, but they're not really. I think I tried to demonstrate a C++ floating point error last time, and I failed. But we saw that when we divided by what we thought was going to be 0, we got a very large value. Not as large as I was expecting, though. Yeah, do you see how rounding errors start to creep in? You know, it counts down 90, 0.80, 0.7, 0.6, and then all of a sudden, after 0.48, we have this, right? And so the rounding error probably occurred even before that. And then we start seeing, you know, it starts looking really weird after a certain point. What is a rounding error? It's because floating point math cannot be exact. Why is that? Because it's stored as base 2. But there are some values you can't store in base 2. 0.2 probably stores perfectly. 0.3 might not. It's just because if you convert a fractional value into base 2, it will not always be able to fit perfectly. Just kind of take that on faith. Fractional values like this cannot be perfectly encoded in binary for all possible fractional values. And so if you start adding things, you know, in sequence or whatever, you can get rounding errors. And that's what we did here. We did not expect it to start looking that weird, because all we were doing is what should have been easy math, 0.01 each time. But anyways, I'm not going to think about how to demonstrate it better. If we wanted to fix it, what we could do is we could copy that cout statement, not that this is a fix, paste it, and then, you know, force it to do division by 0, just to prove the point. And in that case, I should make it greater than 0 rather than greater than or equal. You have to make all those things no, but okay, we finally got to a very large number.
Will you scroll down for a minute, please?
Yeah. In fact, why don't I get rid of that? That was pointless frippery. Which point do I need to look at?
Right, we're good.
Okay. All right. We good to go?
Yeah.
Okay, cool. So the prototype in the definition must indicate the data type of the return value. You can't return anything from a void function unless you're going to use a reference and pass it back via the parameter. The calling function should use the return value, right? Otherwise, why are you returning it? But, you know, you can make it just an error code, you know, return value if you were using the parameter to return, you know, something back in a reference. All right, let me talk about something for a minute. Why have I been making these doubles rather than ints? And the reason why is because you can pass an int into something expecting a double just fine and dandy. So down here, when I passed in, you know, my variable was an int and I passed in a 0, hunky-dory, fine. It converted it to a double at this point. But if I wrote this as an int, and I tried to pass a double in, it wouldn't work. It'd round it down to an int. In other languages, yeah, it wouldn't even work. You'd have to cast it first. There's a concept known as overloading functions, where if you want to write a function that accepts more than one data type, you overload it. And I don't believe that this was available to us in Python, so it's worth mentioning. I'm going to write two different versions of a function. One that takes a double and one that takes an int. No. Did I already demonstrate this? Int sum, which takes int x and int y. But then I decide I want to write something that will accept x, y, and z. I don't think I did this. I think that was another class. Okay, so I have a function called sum that accepts 2 numbers. I'm going to write another one that accepts 3 numbers. Int x, int y, int z. And that's what it does. Return x plus y plus z. So down here, I can take advantage of those. Int a is equal to the sum of 1 plus 2. 1 comma 2. Int b is equal to the sum of 1 comma 10 comma 100, right? We have a function with the same name, and the compiler figures out which one ought to be invoked. Right? If we pass in 2 ints, what it does, I forget if this is the absolutely correct term, but each function has kind of a signature, right? It's got a name followed by 2 data types, just like in our prototype. This one's got a name followed by 3 ints. So if we call that name and we have 2 ints, then the compiler is going to hook that one up to that one. If we have that name and the name matches and then it matches 3 integer types, then it's going to invoke that one instead. That's called overloading. I may have said it was called overriding, and that's just because I lectured in my Java class about overriding, which is a different concept. This is called overloading. Overloading sounds bad, right? You know, oh, well, if I've overloaded the bridge, it's going to crumble. No, in programming terms, it just means you wrote a function that accepts more than one data type or a different number of parameters. Pardon me?
Scroll back down, please.
Yep, sorry. I don't think I put hardly anything in my notepad. Well, a little bit.
What was the other number?
1 comma 10 comma 100. Sorry. Come on, get right there where we see both of them. Okay. So overloading is different functions with the same name, but different parameter types. The parameter types can be different. The number of parameters can be different. You know, I could have made a version of sum that took doubles and returned a double rather than an int. That might be a useful thing to do. So I'm going to write one more version of sum that takes doubles rather than ints, and it returns a double. So double sum takes, you know, double x, double y, and it returns, again, x plus y. Now that we have this function, we wouldn't necessarily even need this integer 1 anymore. Why is that? Because if this function didn't exist, then it would just convert any ints to doubles, you know, when we invoked it. But I just wanted to demonstrate. This is our another overload of the sum function. Why do you overload? So that you don't have to worry about the data type so much. Yes, I could scroll down here and I could have made this say sum 2 numbers and sum 3 numbers and stuff like that. But then what if I wanted it to take doubles, you know, as another one, and then I wanted it to also take, you know, bytes as another one, and then I also wanted it to take strings that got converted to numbers, and you wind up with, you know, 20 different methods that kind of basically perform the same function. It's nice if you can give them all the same name. Now they handle POW in a slightly different way. When we went to the definition of POW, they use something that are known as generics or templates. I forget which one C++ calls it. Well, I see the word template right here, so it's probably that one. But if you have one function concept and it needs to be able to handle multiple types of data, then overload it rather than write 3 different names, 3 functions with 3 different names. Right? Don't write this. I'm going to sum 2 ints. I'm going to sum 3 ints. I'm going to sum 2 doubles. Right? Just write one function name and then let the compiler figure out which one needs to be called. Makes your code clearer. Right? If down here I had to call sum and then sum 2 and then sum 2d and sum 3 floats or whatever, you know, makes the concepts more difficult to look at, to understand when you're looking at the code. The cleaner your code looks down here, even if the code up here is more complicated, the better off you are. Returning a Boolean value. Yeah, sure, you can return a bool just as well as any other value. Not even sure why this needs a separate page. The function can return a true or false. So in order to return a true or false, you declare your function as data type bool. And if you do that, it better return true or false, or a variable equal to true or false, right? It doesn't have to have that value true or false hard-coded as a literal. It can be a variable, as long as that variable is of type bool. And then the calling function can use that return value in a relational expression. So we did that for one of our bits of code. I don't ever think I actually made y'all type it. But remember back here when I did try divide, it returned a true or false, and I used that in an if statement. So that if it returned true, I knew that I could trust that variable and I could print it out. And if it did not, then I would print out an error message. Alright, I've gone a while and I've been trusting y'all to tell me when to slow down, but anybody got syntax errors that you would like my eyes upon? Nope. Bummer. I like getting up and wandering around. Local versus global variables. We've talked about this a little bit before. We're going to talk about it again. Very useful concept. A global variable is one that's declared outside of main. It's declared outside of any context whatsoever, but it can be in a namespace. Why do you use global variables? So that they can be shared between functions. So for example, we're going to declare a string called name. We're going to write two functions. One is going to be called input name and one's going to be called print name. I'm going to make them both void. Void get name. And it's going to ask the user to type in a name. So we're going to use a cout and a cin. So cout, what is your name? Question mark. And then we're going to read it into that global variable. Cin arrow arrow name. Alrighty. Now I'm going to write another one called print name. Void print name. Cout, arrow, arrow, your name is, and really I ought to know because I just typed it, but it's going to tell me. Hey, my name is, arrow, arrow, name, arrow, arrow, ENDL. Alrighty, the only way these functions are able to access this name variable, right? We went through a whole bunch of hoops last lecture about how to pass stuff in as references or pointers or whatever so that, you know, this guy could change some data that would be available somewhere else. Otherwise, it would just be a local variable and it wouldn't be able to change. But since it's declared outside of all these functions, we can change it. We can change it in one and print it out in another. And by the way, this is slightly bad programming. And why do I say that? These functions are tightly coupled, meaning that you have to call them in that order. If we called print name without having called get name, then we'll print out garbage. In some languages it would even crash. I think C++ will just print out. I don't even know what to print out. Why don't we find out? Nah. Yeah. Okay, so I have this code here. That's my global variable. Some people like to do things like put G underscore to indicate that it's a global variable. And then everywhere that variable name occurs, but I'm going to delete that. Other people like to put them in namespaces. We'll do that in just a second. And I know I've demonstrated that once before. Okay, so I'm going to go down to main. Let me just close my output window and my error list. Woo, I have all sorts of space now. Okay, so I'm going to get the name and I'm going to print the name. I'm getting some kind of warning when I compile. I ought to figure out what that is. Inspect it a little more carefully. You should just blindly ignore errors, warnings like I am. All right, what's my name? Joe. Oh, great, and it's still doing all that series stuff. Your name is Joe. What would happen if I called get name or print name without having called get name first? So we didn't have any data to print. This is just an experiment. I don't know the answer. So here we go. It didn't blow up. What did it print? Your name is nothing. Okay, fair enough. So why did we use a global variable? What if we had implemented it like this? You don't need to make these changes. But if I took that out and I put name in here, I'm going to undo these changes, so don't bother typing them. And I did that. Is it going to work? Is it going to print out anything after I type my name in? What's your name? Joe. If I scroll up, I'm getting real tired of that series thing. It says your name is without anything. Now, why is that?
His name's local, not global.
Yeah, it's local. How? This is not this, right? So this has no concept of what you typed in over here. Local means that this is valid only between here and here. This is valid only between here and here. How could we get around using a global variable? You could pass it in as a pointer or a reference. Global variables are considered in bad taste. Maybe the PowerPoint will get to that. I need to remember. I mean, see if I can give you a good explanation of why. But for now, just remember that they're considered in bad taste. But you can get away with using them absolutely perfectly. Some languages don't let you use them at all. Python does, Java does not. You can simulate global variables by, I don't even know why I'm talking about Java, but I know at least several of y'all in here have taken Java. You can simulate global variables by making static class members that are constants, or not even constants. You can simulate them. But, okay, so there we go. We're back to having it work. That's the idea behind a global variable. But to make my code look tidier, you might argue whether it's tidier or not, I'm going to put my global variable in a namespace. So above that word string name, I'm going to do namespace, and I can't think of a good one, so I'm just going to call it data. And it's going to have an open brace before the string name and a closed brace after. Now be careful, when you type namespace data, like I just did, watch what it does. Namespace data, and I type the open, it goes ahead and adds the closing brace. And I didn't want it to do that. I had to move the closing brace down to underneath it. Don't let that fool you. Alrighty, now what do I have to do to fix it? These name variables are no longer valid. This is just like that std colon stuff. We could fix it by doing using namespace. Actually, I meant that to be data, not date. I'm going to have to prefix this with the name of the namespace. Data colon colon. And down here, data colon colon. Why would you want to do that? Because you might be bringing in multiple header files, each one that declares their own global variables. Or maybe you have a whole bunch of global variables strewn in your code, but they share names. Remember, we've already created code, I believe, that has multiple CPP files in it in the same project. And if we haven't, then we should. But what if both of them had a global variable defined in them? One was called max, array size, and then the other one was a max array size. And you had program A.cpp and you had B.cpp, and they both tried to create that global variable. When the compiler tried to link it, it go, no, you cannot have two global variables in your project with the same name. How would it differentiate between the two? But if you put them in their own names, in their own namespace, then it's okay, right? Each one could have its own separate namespace, even if the variable names were all the same. It'd be okay if they would be in their own separate namespaces. Are we still good, or have I managed to break your code yet? All righty. So because the variables defined in a function are hidden, other functions may have separate, distinct variables with the same name. This is a weird term, hidden. But variables that are defined in a function are local to that function. They are hidden from the statements in other functions, which cannot access them. Now, this is different than Java. You can't get away with something like this. You see where I have this variable int var? I can't do this. If var is equal to 0, oh, I feel like creating another variable called var. Double var is equal to 1.23. That's not valid in Java. It is valid in C++. Don't remember if it's valid in Python. It's bad programming in any language that supports it. But this works. And then if you print out var here, then don't type all this. I'm just going to wind up deleting it or commenting it out again. If I printed out var here, it's going to print out 1, 2, 3. Right? We just created a var variable. We gave it the value 1, 2, 3. So when we print it out, it's going to say 1, 2, 3. But if we come down here and we print out var, what's it going to print? Certainly not going to print 1, 2, 3 anymore. It couldn't even be 1, 2, 3, right? Because this is an int. So this variable only exists between here and here. And so when we try to print var out, it's going to print 0 out. So this one effectively hides that one, or masks it, right? We can't get a hold of that one anymore for the duration of this block. We can get a hold of it again later when we exit that block. I don't think that that's what that slide is meaning by that term. I guess I'm going to go ahead and put this in as a comment. This var hides the integer version with that same name. My typing has gotten worse. I'll put a comment here. This will print 1.23, and this will print 0. All right. So because the variables defined in a function are hidden from other functions, is what it should say. Other functions may have separate variables with the same name, right? You could have the sum function and it calculates something called result, and you could have the invert function and it calculates something called result. No problem. But if you want them to share a variable name, why is this not talking about globals yet? We don't understand locals. We understand variable lifetime. The function's local variables exist only while the function is executing. Once it hits that brace, the closing brace within the block that held the variable declaration, that's it. Variable no longer exists. That's known as the lifetime of the local variable. So when the function begins, its local variables and its parameters are also considered local variables, are created in memory. And when the function ends, or when that closing brace is found, the local variables are destroyed, as are the parameter variables. This means that any value stored in a local variable or parameter is lost between calls to the function. A global variable is one that's declared outside all the functions in the program, just like we made our name global by declaring it outside of all of our functions. So the scope of that one is from the point where it is defined all the way to the end of the file. So this one right here, where we created a global variable called name, it's available to the program all the way down to the end of the file. But it's not available up here, right? It hasn't been defined yet. That makes sense, right? But usually you declare your global variables up at the top of the code. Now I'm not spotting it. I'm scrolling too fast, right? Normally you declare your namespaces up at the top of the code. So I'm going to cut that namespace, brace, string name, in brace. I'm just going to cut it and push it up to the top of the code right underneath our using statement, or maybe even above it. Cut, scroll up to the top, put it above my using namespace. That's the right place to define your globals, right? Because you want it available to the... If you didn't want it available throughout the code, then you wouldn't have declared it as a global. I'm itching to go back to the concept of header files, but I don't want to interrupt this chapter. I'd like to finish this chapter. So you should avoid using global variables. They make programs difficult to debug. It says any global you create should be a constant. All right, I'll buy that. That's good advice. For our program, as we wrote it, we could not make it a constant because otherwise name couldn't be changed, right? If we marked name as a const right here, then get name would not actually let us change it. I could be wrong. Let's find out. There were build errors. Didn't think I was wrong on that one. All right. You know what? I haven't compiled it since I made that namespace change. Apparently, I broke the code worse than I had expected. Oh. It took me a second to spot it, but can anybody else spot what's wrong with this code?
Using namespace.
Using namespace should be above everything. It would be like if I had done this, right? See out, you know, hello. Can I see out hello before I have my using namespace? No, because it wants me to type std::, because I don't have the using namespace. Even that doesn't seem to be fixing it. But if I move this up here, then it'll work. Surely. Yep, now it knows what a string is. Without that using namespace, I would have to put std::, string in front of it, because the name class is defined within a namespace in some other code called std. Let's find out where strings are defined. Right click, go to definition of the string, and it's just a type def of another one. Alright, so we would have to find out what a basic string is. Go to definition of that. Alright, and it says that this is a template. And you know, that's kind of a rabbit trail of things trying to figure out what it is. Why do I keep popping up? Because it's red. That's what I want. So initializing local and global variables. Local variables are not automatically initialized. You have to give them a value. But globals do get initialized to 0 or null or false. If it's a Boolean, of course, it goes to false. If it's a number, it goes to 0. If it's a string or another object, it goes to null. That means I can get, that's why I was able to declare name as empty, or as not give it a value, and it still kind of worked. It didn't actually let us do anything when we printed it. It printed nothing. But if I went into my code and I did this, you don't have to do it. Just remember this in your brain. If I did int g value, and then I print out g value here, it's going to print 0. The very top line of code, and it's going to be a 0. Because all global variables have a default value of 0 until you give them something else. Yeah, okay, great. If this was declared inside main, it does not get that nice tidy default value. Instead, it's going to be nasty looking. There were build errors. What's the build error? Well, I don't know what kind of g value has. Uninitialized local variable. Okay, so I got away with using it out here because global variables are initialized. They're initialized to 0. Local variables are not. So global variables get initialized to 0 or false or null, which are all just variations of the value 0. Local variables do not. I should add the word by default. Is that super duper important? I don't think so, because every time I create a variable, I would probably want to give it a value, in my opinion, right? Why would you? But on the other hand, in that name variable, I didn't give it a value, right? I just said string name. I didn't say string name equals. What I would have done in production code if I was going to use a global variable and I was going to use that string name business is I would have gone ahead and given it a default value like this, just out of habit, because other languages might require it. Single equal, not double. Or I may have even done not set, right, so that when it printed it out, I would know that it had never been set. Okay, I think that we have gone just about far enough, but I also think that we have just about hit the end of the chapter. Doesn't look like it, but we really have, because we've already talked about static variables. Static variables are ones that don't lose their value between calls to the function. just like global variables. Default arguments. We've talked about default arguments, have we not? Yep, okay. Default arguments are when you say, X, but if you call it without giving it an argument, it treats that parameter as though it's got 0 in it. Reference variables. We've talked about that. And then we even talked about pointers. Overloading functions. We've talked about that. That's when you have functions with the same name but different parameter lists, like our sum function. It took both ints and doubles, and it took different numbers of arguments. The exit function. Exit is like return, except it just flat out kills your program. Just for funsies, let's put an exit inside one of our functions, maybe times 2. So instead of return 2, go to your times 2 function and let's just put an exit right there. So when it runs, it's going to ask for a name. Whoops, I've got errors somewhere. Yeah. Let me correct that. All right, it's going to ask for my name. It's going to print it out, and then boom, it blew up. Or it didn't blow up, it closed. It's like the return statement in main, right? If you return out of main, your program is done. But you could kill your program from anywhere in your code. You can call exit. And what is that 0? It's just like the return 0 out of main. If you wanted to return something out of main that wasn't 0, you'd type in return 100 at the bottom of main. But you can do exit 100 and it serves the same purpose. Now why would you do that? Maybe the program is in such dire straits that you're just going to give up, right? It's not going to be able to run at all. So you could print out a little warning message that says, program is about to terminate, hit enter to continue or whatever, and then call exit. Now is exit a really good thing to do? Probably not. You're making the program just flat out die, when a certain condition is reached. And usually that's infuriating, right? You're running Word and it suddenly says, illegal operation performed and Word is gone. It's not really a good idea. But that's what exit does. I don't use it in my examples. I don't think that it's good style to use. But if you have to handle some error condition just by giving up, that's one way to do it. All right, and C standard lib header, # include C standard lib, has 2 constants, so that if you wanted to, you could do exit success or exit failure. And I believe that success is just going to be defined as 0 and failure is going to be defined as -1, something like that. Stubs and drivers, we are going to say that for another day, but we've already got the concept. You can flesh out your program just defining functions and then not make them do anything. Maybe they just print a message, right? And then you go back in and you fill those functions in later. And the driver is the code that calls it, also known as the client. Main is our driver because it calls all of our other functions, meaning that the main function is our client to all those other functions. Alrighty, we're done with the chapter. Let's make a Dropbox for a code. We can hang out for a few minutes if you have questions over homework. I should give you a homework assignment. All right, there's a Dropbox P. Dropbox P is what we're going to use today. We do need some kind of homework. So you're just going to write a couple of functions. Write a function, except I'm going to specify that it's a void function, that asks the user for their name. It accepts a reference parameter called name, which is a string called name. The function passes back its value in that reference variable. So that's one of them. Then write a function that does the BMI calculation based on two values passed into it, height and weight, and returns the BMI. So it will be defined. The function needs to have a return type of double. All right, just as a reminder, the BMI equation is 703 times their weight divided by height times height. So those are the two parts of the homework. And really, your client ought to at least call these functions, right? Otherwise, why did you write them? All right, that will be due a week from today. Let's see how we're doing on our load of assignments recently. Yeah, it's time for a new one because we don't have any due next week. So now we do. That's homework assignment 12. Or we could make it 9 because we have that mysterious skipped number there. I'll do that. All right, so this is homework 9. Pardon me? All right, gang, we're done. Have any questions, stuff like that?